Oh man, example 5 is another rational inequality, which we will be following the same steps that we did before. So guys, if you thought you understood example 4, I highly encourage that you try this one on your own, fast forward to the end, and see if you get it correct. Otherwise, just follow along and have fun with the rest of the class. Okay, so step 1, find the LCM. Okay, which typically, you guys, we find the LCM after we factor, if there is any factoring needed, which this one doesn't need to be factored because all my denominators are degree 1. Okay, so we need to find the LCM. That's our first step. Alright, so our LCM, remember I grab one of every different thing I see in the denominator that's a factor, which remember you guys, factors are things that multiply together. So I have a 2, I have an x, and I have an x. So these are the different factors in my denominator. So I have a 2 here. I don't have any more 2s, so that must be in my LCM. All right, but I have an x and an x. Oh no, what do I pick? Well, guess what, you guys? Since both of these x's are to the first power, it doesn't matter which one I pick. So it's just going to be 2x. So step 1 is donezo. Bam. Step 2 is we're going to find the LCM where it's undefined. Okay, remember this is one of our critical values, so it's going to go on our number line. And remember, since it's the undefined portion, it must always be an open bubble on your number line. Okay, so let's set this LCM not equal to 0. So I have 2x cannot equal 0. Alright, let's solve this thing. So 2 is secretly multiplying to my x, so the way we move it to the other side is by dividing both sides by 2. So 2 divided by 2 cancels and turns to 1, so we're left with x cannot equal 0 divided by 2 is 0. Okay, so this is one of the answers that will go on my number line, and remember this is going to be an open bubble on my number line. So don't forget that. This value right here in the undefined, no matter what, it's always an open bubble because since it's in the undefined part, it will not work in my equation or my inequality. So it will always be an open bubble. Okay, so step 2 is donezo. Bam. Step 3, make the inequality in equation and solve. Which remember, whatever we solve for is another critical value, which means it goes on our number line. And the original inequality tells me if it's an open or a closed bubble, which, since my original inequality is an open bubble, since my original inequality is not equal to, it's just greater than, okay, this is going to be an open bubble. Okay, our previous example problem was an equal to, which made it a closed bubble. So if it's equal to, it can equal it, so we shade it in. Since this is greater than, not equal to, it can't equal it, so we're going to leave it as an open bubble. So whatever I get here will be an open bubble. So let's start solving. Okay, so I'm going to rewrite this with an equal sign, and remember, I'm going to leave some space in between each piece so I have room to multiply the LCM to it. So I have 1 over 2x is greater than 2 over x minus 1. Alright, so remember, you multiply the LCM to every single numerator in the equation. So let's see what happens. Alright, so my LCM is 2x. So I'm going to multiply every single numerator by my 2x. Every single piece. So let's go. And remember, the goal is to make my denominators disappear. We're not going to have any fractions left when we get done with it. Who's ready to be a math magician? I know I am, so I hope you guys are. Okay, so now let's start solving this thing. So looking here, holy hot dog, I have a 2, so my 2's are going to cancel. Bam, karate chop, they're gone. And my x's will also cancel out. Bam, bam. So all I'm left with is this 1. So I'm going to have 1 is greater than, here, my x's are going to cancel. Bam, ah, goes away. So I'm left with is 2 times 2, which is a 4. And then minus, I don't have any denominators to cancel out. I can't karate chop anything. So I'm just going to multiply. So negative 1 times 2x is a negative 2x, or minus 2x. Alright guys, let's solve this thing for x. So I need to get my 2x by itself. Okay, so I'm going to move this 4 to the other side. Okay, so the way I move positive 4 to the other side is by subtracting it. which 1 minus 4 will turn to negative 3. So I'll have negative 3 is greater than, 4 minus 4 cancels out and turns to 0. So we have negative 3 is greater than this whole thing right here, which is a negative 2x, which I'm actually going to write it like this. I don't really like to write it like that, so I like to write it as something separate. So we get negative 3. I'm going to write it over here. Negative 3 is greater than, so I wrote my negative 3 here. Greater than, 4 minus 4 cancels and turns to 0. So that leaves me with my negative 2x. Alright, you guys, so I went from here to here. And I'm going to go from here probably to here because I'm out of space. Okay, but anyway, so now I need to move my negative 2 to the other side, which, since my negative 2 is secretly multiplying to my x, the way we move it to the other side is by dividing it. Now, you guys need to be careful. And hold on, you guys. Actually, Miss Long made a boo-boo. Sorry, you guys, I just realized this. It's not a big boo-boo, so don't get too mad. You can get mad at me, but don't get too mad. What was Miss Long supposed to do with this inequality symbol? Make the inequality an equation. Equation. I got so caught up in solving, I forgot to make my inequality an equation. So what I was about to tell you actually doesn't matter. So sorry, guys, just make all these equal signs. I'm sorry. We should have equal signs and not inequalities. Okay. Sorry, you guys. Jeez, Miss Long, what is your deal? We should all be equal signs. Okay, we pretend like it's an equal sign, remember? Okay. Okay, so again, once you find the LCM and find where it's undefined, we solve an equation, and remember, we turn our inequality into an equal sign to solve for our critical value. So, don't make that mistake like Miss Long just made. I'm glad I caught myself, though, instead of waiting until the end of the video, like sometimes that's what happens. But anyways, I will stop rambling and keep solving. So my negative 2 divided by negative 2 cancels out and turns to 1. So I'm left with x. I like to write my x first. Remember, that's the only thing I'm super OCD about. So x will equal negative 3 divided by negative 2, which I'm going to leave it as a fraction, and a negative divided by negative is a positive 3/2. Okay, so this is our other critical value. Our first one was this one. This was a critical value, which all that means, you guys, is it goes on our number line. And remember, since this is not equal to up here, that makes this one an open bubble. So both of these are going to be open bubbles on my number line. Now I just need to figure out which one goes where. Okay, so my smaller number goes on the right-hand side. So between 3/2 and 0, what is the smaller number? You guys are so smart. It is 0. So 0 is going to go on the left-hand side. And my larger number is 3/2, so I'm going to put it on the right-hand side. Okay, and both of them are an open bubble, so I'm going to go ahead and make them an open bubble before I forget. Because usually if you leave something alone for a little while, you kind of forget. So I would just go ahead and do it before I forget. Okay, so after we made the inequality an equation, don't be a dummy, remember to do that, unlike what Miss Long did. We made our inequality an equation, we solved for a value, and we put these things on a number line. So now we had to check the intervals to see which region makes the original inequality true. So we're going to decide if this final answer is an AND inequality, which means we shade in between, or an OR inequality, which means we go the opposite ways. Okay, so let's see here. My first region's over here, and these are things like -1, -2, -3. These are things that are smaller than 0. And don't forget, we cannot equal 0 because it has an open bubble. So this first region is x is less than 0. Now remember, you guys, the only purpose of this is for me to test something in this section. What we're trying to figure out is if this final inequality is true depending on what I substitute into it. Okay, so remember, I'm not solving to see if x is less than 0. This is just going to help me pick an x value. So an x value that is less than 0, I don't know, I'll pick -1. Why not? So x is -1. Okay, so what I'm going to do, you guys, I'm going to take this -1, I'm going to substitute it everywhere I see an x in my original inequality, And at the end, this side better be greater than this side. Okay, so we have multiple things we're going to be substituting in this time. So let's see what happens. All my x's are going to transform into a negative 1. So I have 1 right here, 1 over 2. I spot an x, which is going to transform into my negative 1. 2 times negative 1 is greater than 2 over, I spot another x, so it's going to transform into a negative 1. And then minus 1. So my goal, you guys, is to see if this is true. If this side is greater than this side. That's what I'm looking at. I'm not looking to see if it's less than 0, so be careful. Okay, as of right now, I don't care about this right now. Okay, so let's solve this thing. So 2 times negative 1 gives me a negative 2. So I have 1 over negative 2. So I'm going to see if negative 1/2 is greater than whatever I get over here. Let's see what happens. Okay, so 2 divided by negative 1 is negative 2. And then minus 1. Okay, so I have negative 1/2 is greater than negative 2 minus 1 is negative 3. So let's think about this. Is negative 1/2 a larger number than negative 3? Yes, it is, because negative 1/2 is much closer to 0 than negative 3. So yeah, this works. Yay! This works. So this is going to be one of my final answers, which means I can go ahead and shade in this inequality, or this, this number line. Alright, so I already see that one of my outer regions is shaded in, so I kind of have a feeling it's an OR, but it doesn't hurt to check because, again, all mathematicians are inclined to make mistakes. So it's good to do this because the best thing, you guys, is to make sure you can check to see if what you're doing is correct. And mathematicians, the ultimate goal is to learn from your mistakes or to catch your mistakes. So even if we make a mistake in here, if we can catch it, which we will, if you guys solve for this region and you get that it also works, you know that something's wrong because it's either an or an and. It can't be both. So this is a good way to check to see if what you're doing is correct. So let's check something in between here. So these values are things like, I don't know, 1. 1's definitely in between 0 and 3/2, which is 1.5. Okay, so x is greater than 0. 1 is greater than 0, so this is greater than 0. And remember, it cannot equal 0, so we don't put the line underneath it. And it's less than 3/2. Again, it can't equal it, so we don't put the inequality symbol. So something that's in between 0 and 3/2, or something in this region that I can test, is 1. So I'm going to test x equals 1. And again, these are the things that we test, you guys. Okay, so this is what we're testing. I could have wrote test over here, but I forgot. It doesn't really matter. Okay, so again, I'm going to substitute 1 back in for all these x's and see if I get something true. So let's see what happens. Okay, so I'm going to have 1 over 2 times x, which my x is going to transform into a 1. So it's 1 over 2 times 1 is greater than 2 over another x, which is going to transform into a 1. And then minus 1. Alright, let's see what happens. Okay, so 1 over 2 times 1, 2 times 1 is 2, so this will be 1/2, is greater than 2 over 1 is 2 minus 1. And 2 minus 1 is 1. So is 1/2 greater than 1? Is half greater than 1? Oh no, it's not. It super fails and we're sad because we always want it to work. So this interval will not work. This one's not going to work. Section 2, sorry, I probably should have labeled these as well. This is section 1. Section 2 does not work, so I'm going to cross it out. Okay, so I cannot shade that region because it didn't work. Okay, and then my final region, these things over here, things like 2, 3, 4, etc. Okay, so these are things that are larger than 3/2. So x is greater than 3/2. And it does not equal 3/2 because of my open bubble. Alright, so something that's greater than 3/2, so I'm going to test, I don't know. Remember, you kind of want to pick something that will work up here. So I'm going to be dividing by 2, so I probably want to pick something that 2 can be divided by, which 2 is an option. So why don't I pick that? Might as well, right? Make my life easier. So I have anywhere C and x is going to transform into a 2. So I'm going to test x equal to 2. Okay, all my x's are going to change into a 2. So I have 1 over 2 times I see an x, so it's going to transform into a 2. Okay, is greater than 2 over, I see another x, so it's going to transform into a 2. Minus 1. All right, guys, let's see what happens. So 2 times 2 is 4, so this is 1/4. Let's see if 1/4 is greater than all this. So 2 divided by 2 is 1, and 1 minus 1 is 0. Is 1/4 greater than 0? Holy hot dog, it is. Yay! It works, and we're happy. Yay! So that means that this region is also going to work. Yay! So I get to shade it. Yay! Okay, so since my arrows go opposite ways, this is an or. So these are my answers, you guys. This is why it's useful to write the inequalities before you solve. So I'm going to have x is less than 0, or x is greater than 3/2. And that, my friends, would be my final answer. So this is an or, and it was awesome. Oh man, don't you guys just love rational inequalities? I love them too. They're so much fun, and the longer the problem, the more exciting the problem. So yeah, definitely.